In this video, I want to talk about a special kind of central tendency problem that deals with the mean. Before we look at that problem, let's just review what we know about calculating the mean, right? If we had, say, we had three numbers, we had 4, 8, and 12. To find the mean of these numbers, the first thing we do is add them up. We find the sum. Well, 4 and 8 is 12, and 12 is 24. And then we divided the sum by the number of numbers. So to find the mean, then we'll take 24. There are three numbers. 24 divided by 3 is 8. So the mean of these three numbers is 8. Let's do another one. Suppose we had 1, 2, 3, 4, and 5. And I want to find the mean of those numbers. So again, I add them all up. 1 and 2 is 3, and 3 is 6, and 4 is 10, and 5 is 15. So the sum is 15. Find the mean, we take that sum, we divide it by the number of numbers. Well, there's 1, 2, 3, 4, 5 numbers. 15 divided by 5 is 3, so the mean of those numbers is 3. Now I want to try to do something here. Let's go back to the first example. Now remember we said the mean of these numbers was 8. Suppose I replaced all of the original numbers, the raw numbers, with the mean number. So instead of writing those, I write 8, because that's the mean. Now if I take these numbers and I add them up, 8 and 8 and 8, 3 8, that's 24, I get the exact same sum as I got when I added up the raw numbers. And the mean of these numbers is, again, calculated. The sum was 24. There was three numbers. 24 divided by 3 is 8. So the mean was also the same. That's kind of weird. Let's look at this next example, see if that still applies. So the mean was 3. I take every one of the original numbers and I replace it with the mean. So this one becomes a 3, this one becomes a 3, this one becomes a 3, 3, and 3. So again, to add those up, if we find the sum of those numbers, 3, 6, 9, 12, 15, it's the same sum as we got with the original numbers. And the mean of these numbers, 15 divided by 5 is 3. So we get the same mean also. So what this tells us is that the sum of the raw numbers, or the original numbers, is equal to the sum of mean numbers, if all those numbers were the mean. Yep. This is going to come in handy in just a minute. Let's try another problem. And this is the special kind of problem that I originally wanted to deal with. Suppose they say, okay, I've got 4 numbers. The first one is a 3, then a 6, and then a 12. But I don't know what the fourth number is. So I don't know what the sum is. But what I do know, I know the mean. And the mean in this case is 6. My job is to find out what's that missing number have to be in order for the mean to be 6. Well, we can use that same little sort of trick that we did on those first two problems. We can replace the original numbers, including the one we don't know, with the mean number. The mean was 6, so we make them all 6. Now if we add these guys up, 6 and 6 is 12, 18 and 6 is 24. Remember we said the mean of the original numbers, the sum of the original numbers has to be the same as the sum of if they were all the mean. So this number up here also has to be 24, right, to match this one. Well, how much do we have so far? We have 3 and 6 is 9 and 12 is 21. In order to get to 24 minus 21, this number has to be a 3. So we use that trick of changing all of the original numbers to the mean, found their sum, and then use that sum to figure out what the missing number was. Let's do another one. Suppose we had, let's see, 6, 7, we had 8, and we had, let's say, 12. And I'm trying to find that last number. And I know that the mean of these numbers has to be 7. But I don't know the sum, right? So what's this fifth number have to be? Again, we use that same trick. We're going to take all the original numbers, including the one we don't know, and we're going to replace them with the mean, which was 7. If I add up these guys, 1, 2, 3, 4, 5 sevens, the sum, 5 sevens, is 35. And remember that the sum of the raw numbers has to be the same as the sum of the mean. So I know that this number has to be 35. Well, how much do I have so far? I have 6 and 7 is 13, and 8 is 21. 21 and 12 is 33. I just need 2 more to get to 35. So that last number has got to be a 2. And remember, if they ever ask you on the HSE test, and they well might, if they give you all the numbers except 1, and they give you the mean, you can use this little sort of trick to figure out what is that missing number. We'll talk about more of these in class, but for now this should hopefully make some sense to you, and we'll get a chance to practice it pretty soon. Done.